Today, we will learn about the representation of rational numbers by decimals. Students, you should recall from our last lesson that rational numbers are numbers that can be written as simple fractions or ratios. More formally, we say that a rational number is any number that can be expressed in the form A over B, where A and B are integers and B does not equal 0. Today, we will learn how to express rational numbers in the form of fractions and decimals. If you are ready, students, let us begin the lesson. I am sure that you are all familiar with decimal numbers. If you see the number 0.5, you know that this means 1/2. A half can also be expressed as a fraction, 1/2. A fraction is another way of writing the division of one quantity by another. Any fraction of natural numbers can be expressed as a decimal by dividing the numerator by the denominator. Let us look at the fraction 4/5. This means 4 divided by 5. If we divide 4 by 5, we get 0.80. This is an example of a terminating decimal because the division ends when the remainder is 0. Please try these examples, students. Express the fractions 2/10 and 5/9 as decimals. Let us review the answers together. The first fraction converted to a decimal quite easily. The fraction 2/10 is expressed as 0.20. But the fraction 5/9 is expressed as 0.5555, and it keeps going. This is because 9 goes into 50 5 times with a remainder of 5. Students, this is an example of a repeating decimal. To show a repeating digit or block of digits in a repeating decimal number, we put a bar above the repeating digits. In this case, our repeating decimal would be written as this. This is known as bar notation, and the portion of the decimal that repeats is called the repetend. Students, we have just seen that any rational number a over b can be expressed as a decimal by dividing the numerator a by the denominator b. In the same way, every terminating decimal can be expressed as a fraction with a denominator of 10, 100, 1,000, and so on. For instance, the decimal number 0.37 can be expressed as 37 over 100. Remember, students, that the places to the right of the decimal point provide us with our denominator. The first place denotes a tenth. The second place denotes a hundredth, and so on. If D is a terminating decimal number that has n digits after a decimal point, then we write this as D equals 10 to the power of n times D over 10 to the power of n. Students, please express these decimals as fractions in their lowest terms. 0.45, 0.9, and 1.8. Welcome back, students. Please compare your answers with these. 0.45 is expressed as 45 over 100. This can be simplified as 9 over 20. 0.9 is expressed as 9 over 10. 1.8 is expressed as 18 over 10, or 9 over 5. You could also write this as 1 4/5. Good work. Repeating decimals can also be expressed as fractions. Take the repeating decimal 0.45, for example. We will use the letter D to represent the repetend. We multiply D by 100 because there are 2 digits that repeat. 100D equals 45.4545, and so on. By subtracting 1D from 100D, we eliminate the repetend. We are left with 99D equals 45. Therefore, D equals 45 over 99. The algebra that we just used can be generalized as follows. If D is a repeating decimal with non-repeating and repeating digits after the decimal point, represented by K and P respectively, then we use this formula to change the decimal to the fractional form of D. D equals D times 10 to the power of K plus P minus 10 to the power of K divided by 10 to the power of K plus P minus 10 to the power of K. Students, please use this formula to express the repeating decimal 0.381, where 8 and 1 are the repetends. Let us look at the answer together. D equals 0.381. K equals 1, which is the number of non-repeating digits, and P equals 2, which is the number of repeating digits. Our formula tells us that D equals D times 10 to the power of 3 minus 10 divided by 10 to the power of 3 minus 10. If we substitute our value for D, we get 0.381 repeating times 1,000 minus 10 over 1,000 minus 10. Therefore, D equals 381.81 minus 3.81 over 990. Our answer is 378 over 990. This can be simplified to 21 over 55. Students, today we have learned that every rational number can be expressed as either a terminating decimal or a repeating decimal. The opposite is also true. Every terminating or repeating decimal represents a rational number. That is all the time we have for today's lesson.